Imagine a battery that not only redefines what we know about electric cars, but also seems straight out of a futuristic movie. That's exactly what Tesla is preparing with the so-called A1 battery, a breakthrough that promises to put aluminum at the center of the electric revolution. We're talking about an energy density of $700 when in tour, about 3.5 times greater than the best lithium-ion batteries available today. In practice, this could allow a car to travel more than 700 miles, about 1,126 km, on a single charge, and on paper, up to 1,000 miles. It's like driving from São Paulo to Salvador without needing to stop at a single charging station. And the most impressive thing? The secret lies in an abundant, cheap, and easily extracted element: aluminum. Aluminum, unlike lithium, can carry 3 times more energy per ion, completely changing the game. For those unfamiliar with the technical world of batteries, just imagine that each particle of this metal is like a small truck capable of carrying much more cargo than the current lithium-ion delivery cars. This difference in energy capacity per ion is what allows such drastic leaps in range without increasing the battery's size or weight. And here's a curious detail: aluminum is not only efficient, it's everywhere, from kitchen foil to airplane chassis. And this means less dependence on strategic suppliers and more control over costs and production. This kind of breakthrough doesn't come out of nowhere. Tesla has been quietly working on this project for years, and until recently, almost no one knew something like this was about to be unveiled. It's as if they were quietly building a new heart for their cars, waiting for the right moment to announce it. The choice of aluminum isn't just technical, it's strategic. Besides being easier to find, it avoids the frenetic rush for lithium that has been inflating the market and leaving other manufacturers desperate. It's a move that could completely transform the cost of an electric car. Now, think about it. While many automakers are busy just trying to optimize what already exists, Tesla has decided to practically reinvent the core of the electric car. The A1 battery's record-breaking energy density means that, in the same space, you can store much more energy without needing giant, heavy batteries. This paves the way for lighter, faster, and perhaps even more beautiful cars, since the design won't need to swallow huge packs of cells to guarantee range. Another intriguing point is how this technology could change people's behavior regarding long trips. Today, even with the best lithium-ion batteries, there's always that concern about the nearest charging point. But if a car can travel 1,000 miles on a single charge, the conversation changes. Stops become optional, not mandatory. Imagine crossing borders or taking road trips without glancing at the range indicator, like someone counting down the minutes until they get home when the reserve light comes on. Of course, it's not just about range. This energy density also impacts performance. Less weight and more power mean faster acceleration and more aggressive responses, something that has always delighted Tesla fans. It's the kind of change you feel not just on paper, but in your body, as you feel the car's force pushing you into the seat with much greater intensity. If the A1 battery's incredible range is enough to leave any electric car enthusiast speechless, the financial side of the story is even more tempting. Today, one of the biggest obstacles for anyone wanting to own an EV is the price, and a large part of that cost comes from the battery. Lithium-ion batteries, for example, can reach a staggering $139 per DK. It's as if the car's tank were made of gold. Now, imagine cutting that cost in half or even more. Aluminum batteries promise to be in the range of $40 to $65 per kilopet when mass-produced. This completely changes the equation for those who dream of having a Tesla in their garage without having to sell a kidney. And this difference isn't an optimistic guess. It's based on the very nature of aluminum. Unlike lithium, which is rare and sought after like a treasure, aluminum is the most abundant metal in the Earth's crust, accounting for about 8.13% of it. To put this in perspective, There are global reserves of approximately 1.59 billion tons of bauxite, the ore used to produce it. This means that the raw material for these batteries won't be the target of trade wars or constant geopolitical disputes. And of course, when a resource is abundant, the price tends to be stable and much more affordable. When we talk about making electric cars cheaper, it's not just a matter of making it cheaper for the sake of it. It's also about opening doors to a market that currently wouldn't even consider buying an EV due to the cost. With such a low battery cost, the impact on the car's final price can be huge. We're talking about making models like Tesla's upcoming compact truly affordable, with prices that compete directly with combustion-powered cars. And this isn't just good for Tesla. It's a direct hit to the traditional car market. This reduction could also create a domino effect. If consumers start finding high-performance, long-range EVs at a competitive price, other automakers will have no choice but to follow suit. It's the kind of change that accelerates not only the adoption of new technologies, but also the gradual death of combustion engines. And let's be honest, who doesn't want to see a little healthy pressure on companies still reluctant to change? An interesting detail is that Tesla has already proven itself capable of scaling production when it finds the right formula. The battery manufacturing lines at the Nevada Gigafactory are a clear example of this. By applying this know-how to A1 battery, the cost per unit could fall even faster than analysts predict. This creates a scenario where, within a few years, the average price of a basic Tesla could drop to levels unthinkable today. Of course, some argue that lower prices often mean compromising quality, but in this case, that logic doesn't apply. Aluminum, besides being inexpensive, is extremely strong and reliable. This means that this cost reduction doesn't come with a cheap that ends up being expensive. On the contrary, we're talking about increased durability and safety, which would typically cost even more with other technologies. Now, if the price already makes the A1 battery irresistible, its recharge speed is the detail that can convince even the most skeptical. Think of something that seems impossible today. Leaving home with a dead battery, stopping to charge, grabbing a quick coffee, and before you even finish the last sip, the car is already fully charged. That's what Tesla promises with the 5-minute full recharge of this new technology. It's no exaggeration, and we're not talking about 80% charge, but 100% without the slightest risk of overheating. The magic happens because aluminum ions move much faster in the electrolyte than lithium ions. It's as if, instead of a slow-moving traffic jam, there were a free highway where each particle runs at maximum speed, carrying energy more efficiently throughout the system. And, contrary to what many imagine, this rush doesn't prematurely wear down the battery. On the contrary, aluminum's chemical structure handles intense movement better, maintaining consistent performance even with repeated fast charges. Anyone who's ever had to wait 20, 30, or even 40 minutes at a supercharger knows how frustrating it can be, especially on long trips. And it's not just the wait. There's always the concern about thermal stress, as rapid charging can heat up the cells significantly. With the A1 battery, this problem simply disappears. Aluminum dissipates heat more efficiently, preventing overheating and ensuring the car is ready to go immediately, without risk. This feature could completely change the way people plan their trips. Today, EV drivers still need to plan routes around availability and charging time. But with a 5-minute full charge, the mindset changes. Recharging ceases to be a strategic stop and becomes simply a natural pause, like filling up a gasoline car. This brings the electric experience on par with that of a conventional vehicle, and in some cases, even surpasses it. And here's a detail that few people realize. With such fast recharges, the need for large battery packs may decrease. Why carry the weight and cost of a giant battery when you can stop for a few minutes and get back on the road? This opens the door to lighter, cheaper, and still extremely practical cars. The A1 battery isn't just about incredible range, It's about redefining the concept of fueling a vehicle. Another consequence of this is the impact on infrastructure. If recharging becomes as fast as refueling, charging stations will need fewer locations to serve the same number of drivers. This could accelerate the installation of charging networks in locations that would currently be economically unfeasible. For countries still in their infancy regarding electrification, this is a powerful gateway. If the recharge speed already places the A1 battery on a different level, its durability is the kind of detail that transforms this technology into something almost legendary. Imagine a car that runs for decades without needing to replace the battery, maintaining virtually the same performance as when it left the factory. With the A1 battery, this stops being a dream and becomes a concrete possibility. We're talking about up to 15,000 charge cycles, which is equivalent to about 35 years of use for an average driver. That's so long that the car will most likely change owners several times before the battery needs replacing. This longevity has a fascinating chemical secret. Aluminum naturally forms a protective oxide layer that prevents corrosion and accelerated wear. It's as if each cell has an invisible shield, protecting its interior from the most common battery enemies. Furthermore, aluminum's charge structure is much more stable, which prevents chronic problems such as the formation of dendrites, those microscopic needles that can pierce internal separators, causing failures or even fires in lithium batteries. Another point is that, unlike lithium, aluminum doesn't react aggressively with oxygen and moisture. This means less degradation over the years, even in more humid or hot climates. For those who live in regions where temperature and humidity vary greatly, this extra resistance can be a decisive factor in keeping your car in perfect condition for longer. It's a type of security that goes beyond performance. It's the peace of mind of knowing that the heart of your car is protected. And when we talk about resistance, we don't just mean it in the chemical sense. Aluminum is physically robust and is already used in the structures of airplanes, trains, and even race cars. This robustness translates into greater tolerance to impacts and vibrations, something that inevitably occurs in daily use. Lithium batteries can lose efficiency or even become damaged with strong impacts. Aluminum batteries, on the other hand, are much more resilient. This combination of chemical stability and physical strength also means the battery maintains its charge capacity for much longer. While a lithium battery begins to lose noticeable performance after a few years, an aluminum battery maintains an extremely slow degradation curve. This is particularly important in the used car market. A Tesla equipped with an A1 battery can be resold years later with nearly intact range, which increases the vehicle's value and attracts buyers. Now, consider the impact this has on fleets and transportation services. Companies that rely on vehicles for daily operations could operate for decades without significant battery replacement costs. This eliminates one of the largest operating expenses in the industry and completely changes the return on investment calculation. It's an economic advantage that could accelerate the adoption of EVs on a commercial scale. In addition to everything already mentioned, the A1 battery also has an ace up its sleeve that addresses two major public concerns: safety and environmental impact. Anyone familiar with the history of lithium batteries knows that, despite advances, they still carry a considerable risk of overheating, fire, and even explosion in extreme cases. A strong impact, an internal defect, or overcharging are all it takes for everything to spiral out of control. Aluminum, on the other hand, is chemically stable and much more resistant to thermal variations, virtually eliminating this type of hazard. This means that, with the A1 battery, the likelihood of seeing a Tesla burst into flames due to battery failure drops to almost zero. This stability isn't an insignificant technical detail. It completely changes how people perceive the safety of an electric vehicle. Knowing that the battery won't become a life-threatening hazard in the event of an accident or failure provides an extra level of confidence. This also makes it easier for automakers to comply with standards and certifications. as aluminum naturally meets stricter standards without requiring such complex and expensive safety systems. And when it comes to sustainability, aluminum shines even brighter. We're talking about an abundant material, easy to extract, and with an extremely efficient recycling process. Studies show that up to 80% of the aluminum fluoride salts used in batteries can be recovered, and the aluminum foils that make up the anode can be reused almost directly after cleaning, without the need for expensive and polluting industrial processes. This not only reduces costs, but also drastically reduces the product's environmental footprint. Efficient recycling also means less waste and less reliance on intensive mining. While lithium, nickel, and cobalt are concentrated in a few countries and require extraction processes that destroy entire ecosystems, aluminum is widely distributed across the planet and can be obtained with much less environmental impact. This decentralization also helps avoid supply crises that could paralyze EV production. Another point worth highlighting is how this sustainability influences the brand's image. Companies and consumers are increasingly aware of the origin and life cycle of the products they consume. By adopting a battery with easy recycling and clean production, Tesla not only improves its ecological footprint, but also strengthens its reputation as a leader in responsible innovation. It's a move that's both technical and pure marketing. The environmental aspect also has a direct impact on long-term costs. Recycling aluminum is much cheaper than extracting new resources, and these savings can be passed on to the end consumer. This creates a virtuous cycle in which sustainability and affordability go hand in hand, something that rarely happens in the automotive sector. Even with all these science fiction-sounding advances, the A1 battery still faces some challenges that Tesla must overcome before putting it into millions of cars. Chief among them is performance in very low temperatures. In harsh climates, especially below freezing, the speed at which aluminum ions move slows, which can temporarily reduce efficiency and range. It's as if all that agility we saw in fast charging and exceptional performance becomes a bit sluggish in the intense cold. This is a problem that Tesla and other research groups around the world are already working to solve. This climate issue is nothing new in the battery world. Lithium also suffers from low temperatures. But in the case of aluminum, the solution requires adjustments to the electrolyte composition and perhaps the internal design of the cells. The good news is that, unlike structural limitations, this type of problem can be mitigated with clever engineering and controlled testing, something Tesla is very good at. After all, we're talking about a company that has already proven itself capable of taking an electric car to the desert and snow without significantly compromising its usability. Another challenge is the transition to mass production itself. Creating prototypes and test units in a laboratory is one thing. Manufacturing on an industrial scale is quite another. Assembly lines need to be adapted, suppliers need to be prepared, and processes need to be fine-tuned to maintain quality while reducing costs. This means that the first models equipped with the A1 battery will likely come out in more limited batches before the technology is ready for a global launch. Tesla, however, is already moving in this direction. Initial production of aluminum-ion batteries is expected to take place in the United States, at an expanded facility near the Nevada Gigafactory. Operations are expected to begin by the end of this year, once all machinery is installed and calibrated. If this schedule holds, we'll see the first commercial units sooner than many imagine. An interesting factor is that Tesla has the advantage of controlling a large portion of its production chain, which accelerates the implementation of new technologies. While other automakers would need to negotiate with multiple suppliers for each component, Tesla can adjust most of the steps internally. This gives it more freedom to experiment and fix problems quickly, without being tied to rigid contracts or third-party schedules. The introduction of the A1 battery isn't just a technological leap. It's a strategic move capable of shaking up the automotive industry and even influencing the geopolitical landscape. By drastically reducing dependence on lithium, nickel, and cobalt, Tesla is taking considerable power over global electric vehicle production out of the hands of a few countries. Currently, much of the lithium comes from regions like the so-called Lithium Triangle in South America and areas controlled by China, while nickel and cobalt are concentrated in places that frequently face political instability.